Ever wondered how databases are managed and how SQL is the backbone of this complex process? Allow me to take you on an insightful journey through the captivating world of SQL development, a fundamental cog in the intricate machinery of information technology. In today's time and age, the value of data is unparalleled, and so is the need for managing it effectively. We live in the information age, a time where is the heartbeat of our digital lives. Our actions, decisions, and interactions generate an incredible amount of data, which businesses, governments, and organizations seek to collect, store, and analyze. This is where SQL, or Structured Query Language, comes into play. It's considered one of the most important tools for working with data. SQL is the world's most widely used programming language for managing and manipulating databases. Virtually all noteworthy companies use SQL, making knowledge of it an indispensable resource. SQL developers, the wizards behind effective database management, ensure businesses maintain a smooth flow of data. These experts are responsible for designing, implementing, and maintaining databases, a task that requires both creativity and precision. Their essential role involves writing queries for creating, retrieving, updating, and deleting data from databases, as well as optimizing the performance of databases and ensuring data integrity and security. SQL developers are the unsung heroes who work behind the scenes to ensure that businesses can access their data whenever they need it. They make sure that the data is stored in a way that it can be easily retrieved and manipulated, ensuring efficiency and productivity. The demand for SQL experts has skyrocketed in recent years, given the increasing reliance on data in decision. This has resulted in SQL expertise becoming a highly sought-after skill in the job market. SQL developers are in high demand, not just in the tech industry, but across a vast array of sectors, including finance, healthcare, and e-commerce. There is a growing inclination towards learning SQL given the promising prospects it poses for aspiring developers. As we continue to generate data at a faster pace than ever, the importance of SQL and SQL developers will only increase. The future of data management lies in the hands of these dedicated individuals who strive to make sense of this avalanche of data. Stay tuned as we delve into some of the most pertinent SQL interview questions and their answers. Together, we will explore the essential knowledge required to crack these interviews and take a step further into this intriguing universe of data management. So, what exactly is SQL, and why is it so crucial in today's digital environment? SQL, which stands for Structured Query Language, is essentially the universal language utilized for interacting with databases. It is akin to a translator between you and your data. Just imagine having an interpreter who could translate your queries into a language that databases could comprehend. That's what SQL does. It enables you to inquire, make necessary alterations, and even design new databases. This wide range of functionality makes SQL an essential tool in the digital era. SQL's applicability is vast, spanning across numerous industries and professions. It's not confined to a specific area. Whether it's application development or data analysis, SQL is the backbone. It allows professionals to communicate with the data, manipulate it, and derive meaningful insights. This indispensability makes SQL a critical skill in today's digital age where data is the new oil. Now, there might be some confusion between SQL and MySQL. A common misunderstanding is that they are interchangeable terms. However, that's far from true. SQL is the language, the syntax that we utilize to communicate with databases. It's like the lingua franca for databases. Conversely, MySQL is one among many database management systems, or DBMs for short, that implements SQL. Other renowned systems that follow a similar pattern include Oracle, PostgreSQL, and SQL Server. Speaking of DBMs, we need to delve deeper into that concept. It stands for Database Management System and is essentially a software that acts as the intermediary between the user, other applications, and database. It ensures smooth communication and interaction, captures and scrutinizes data. Imagine having a competent manager who supervises the workflow, ensuring everything runs seamlessly. That's what a DBMS does in the world of databases. Take DBMS, add relational to it, and you get RDBMS, which stands for Relational Database Management System. It's a DBMS that organizes data into one or more tables or relations. These tables are interlinked through common data, like a unique identifier, enabling us to access data in connection with other pieces of data within the database. This functionality is of paramount importance in businesses because it allows for effective data management and complex querying. Businesses leverage this to drive decisions and strategies. It helps them sift through enormous amounts of data, find patterns, and extract actionable insights. In a nutshell, SQL is the language we use to converse with our data, and RDBMS is the system that secures and manages that data. Understanding these fundamentals is the first stepping stone to mastering SQL. With this knowledge, you can unlock the vast potential of SQL in data management and analysis. Now that we've covered the basics, let's move on to some common SQL interview questions. Ready for some SQL interview questions? Here's the first one. What is the difference between DBMs and RDBMs? Let's delve deeper into this comparison. A database management system, often referred to as DBMS, is a powerful software that serves as an intermediary between users, applications, and the database itself. It's principally designed to capture, store, retrieve, and analyze data. A DBMS provides a systematic approach to manage data, enabling the end user to perform a variety of manipulations on data. These manipulations are diverse and include retrieval of specific information, insertion of new data into the database, deletion of unwanted data, updating existing data, and the creation of data schemas. On the other hand, we have the Relational Database Management System, or RDBMs. RDBMS is a specialized type of DBMS that stores data in a structured format using rows and columns. It simplifies the process of locating and accessing specific values within the database. The relational in RDBMs signifies the relationship between the values within each table, and this relationship can also be extended to other tables. This structured and relational data storage makes RDBMs efficient and user-friendly. Now that we've covered the difference between the two, let's move on to the next question, which is, what is a self-join in SQL? In the realm of SQL, a self-join is a unique way to combine rows with other rows in the same table when there's a match based on a specified condition. It's used to combine and compare rows within a table to find rows that share certain characteristics. It might initially sound intricate, but once you get the hang of it, it becomes an incredibly powerful tool in your SQL toolkit. Next, let's discuss some common SQL clauses that you are likely to encounter regularly. We start with the where clause. The where clause plays a crucial role in filtering records, and it's typically added after the from clause in an SQL statement. It extracts only those records that meet a specific condition. Then there's the order by clause. This clause is essential when you need to sort the records in your result set. You have the flexibility to sort the records in ascending or descending order, and you can sort them based on one or more columns. The next clause we have is the group by clause. This clause is used in collaboration with the aggregate functions to group the result set by one or more columns. It's a powerful clause that can be used to perform calculations on grouped data. Lastly, we have the having clause. It was added to SQL because the where keyword couldn't be used with aggregate functions. The having clause is similar to where, but it operates on grouped records returned by a group by clause. In summary, SQL is a powerful tool with vast capabilities. It might seem overwhelming at first, but with persistent learning and practice, you can master the and its various aspects. Great job! Let's continue with some more SQL interview questions. Moving on, here's our next question. What are the union, minus, and intersect operators in SQL? These three operators are the pillars of SQL that allow us to manipulate and extract information from databases in different manners. The union operator, as its name suggests, unifies the result set of two or more select statements. It's like a melting pot where rows from different select statements blend together, but with a twist. This operator removes any duplicate rows, ensuring that the result is a unique collection of rows. It's important to note that each select statement within the union must have the same number of columns, and the columns must have matching data types. This is to ensure consistency and avoid errors. Then we have the minus operator. This operator is not about merging, but about distinguishing. It returns unique rows from the first select statement. It's like an elimination process, saying, give me everything from the first set that's not in the second. Similar to union, the select statements must adhere to the same rules of having the same number of columns and matching data types to ensure accurate results. The intersect operator is the bridge between union and minus. It doesn't combine all, nor does it eliminate. Instead, it seeks commonality. It returns the common records between two select statements. In essence, it's like saying, give me everything that's in both sets. Continuing our SQL journey, let's dwell upon the concept of cursor usage in SQL. A cursor in SQL is a database object akin to a spotlight, illuminating a specific set of rows from a query for processing. It's like a compass pointing to a context area. Cursors become essential tools when you're dealing with multiple rows but need to process each row individually, giving you precision and control over your operations. Shifting gears, let's explore the different types of relations in a database. In a relational database, we have three types of relationships: one-to-one, one-to-many, and many-to-many. A one-to-one relationship is like a committed connection where a single record in a table is associated with a single record in another table. On the other hand, in a one-to-many relationship, one record in a table has the freedom to associate with one or more records in another table, creating a network of connections. In a many-to-many relationship, it's a social gathering. Multiple records in a table are associated with multiple records in another table, creating a web of interconnections. Now, let's delve into the concepts of OLTP and OLAP. OLTP, or online transaction processing, is like a cashier at a supermarket, capturing and storing data from transactions in real time. It's a tool mainly used in routine operations such as order entry. OLAP, or online analytical processing, on the other hand, is like a strategist. It's a computing method that enables users to easily and selectively extract and view data from different points of view. It's used for complex calculations, trend analysis, and sophisticated data modeling. Well done! Now let's move to some advanced SQL interview questions. Now, let's tackle an advanced question. How do you create empty tables in SQL? This seems like a simple question, but it's a fundamental one that every database professional needs to know. The answer is quite straightforward. You would use the create table statement. This statement is a cornerstone in SQL, allowing you to specify the table name, column names, and their respective data types. Think of it as an architect's blueprint. You're defining the structure of your building, or in this case, your database table. Remember, an empty table is just a table structure without any data, a foundation waiting to be filled with data. It's like a blank canvas that's ready for you to create something amazing. Before we move on to the next question, let's take a moment to appreciate SQL's capacity for simplicity and efficiency. The create table statement is a perfect example of how SQL empowers you to manage complex database systems with simple, easy-to-understand commands. Next, can you give a brief history of PostgreSQL? It's fascinating to look back at the journey of this powerful database system. PostgreSQL, commonly known as Postgres, is an object relational database system that emphasizes extensibility and standards compliance. It was originally named Postgres, paying homage to its roots as a successor to the Ingres database developed at the University of California, Berkeley. In 1996, the project was renamed PostgreSQL to reflect its support for SQL, the standard language for managing databases. Isn't it remarkable to think about how far we've come in the world of database management systems? Now let's delve into another advanced topic. What is the concept of normalization? Normalization is a database design technique used to minimize data redundancy and avoid data anomalies. It involves dividing a database into two or more tables and defining relationships between the tables. The main goal of normalization is to add, delete, or modify fields without causing data inconsistencies. It's a critical process that ensures the integrity and efficiency of your database. As we forge ahead, let's explore our final advanced question. What are the types of SQL commands? SQL commands can be classified into 5 categories: data definition language, DDL, data manipulation language, DML, data control language, DCL, Transaction Control Language, TCL, and Data Query Language, DQL. Each category serves a unique purpose in managing and manipulating data. DDL commands like create, alter, and drop define and modify the structure of your tables. DML commands such as insert, update, and delete allow you to manipulate the data within your tables. DCL commands like grant and revoke control access to data, ensuring data security. TCL commands like commit and rollback manage transactions to ensure data integrity. And finally, DQL is all about the select command, which is used to fetch data from a database. Congratulations! You've successfully navigated through the SQL interview questions. To wrap up, let's reflect on some key takeaways. Just remember, the more you immerse yourself in these concepts, the more comfortable you'll become. Persistence is key, so keep at it, and you'll be acing those SQL interviews in no time. So, what have we learned today about SQL and its importance in database management? We embarked on a journey from the basic understanding of SQL, also known as Structured Query Language. This particular language is not just a random set of commands. Rather, it's a standard protocol that manages and manipulates databases. Imagine it as the foundation on which data-driven business models thrive. It's a critical tool in the toolkit of any individual aspiring to make a mark in the IT sector. We also took a step further and explored various SQL interview questions, creating a comprehensive guide for those preparing for tech interviews. We unraveled complex topics like the intriguing difference between SQL and MySQL. We provided a detailed explanation of a relational database management system, also referred to as RDBMS, and its pivotal role in organizing and retrieving data. We dived deep into the contrast between a database management system and a relational database management system. Enhancing our SQL knowledge, we touched upon the unique concept of self-join in SQL. We thoroughly discussed common SQL clauses like where, order by, group by, and having. We explained how these clauses act as a powerful tool to filter, sort, and manage data. Then, we moved on to demystifying the union, minus, and intersect operators. We offered an insightful overview of cursor usage in SQL, which allows for more intricate control over the database. We cautiously navigated through advanced topics like various types of relations in a database, and the concepts of online transactional processing and online analytical processing. We unveiled the secret to creating empty tables in SQL, an essential skill for management. We did not forget to take a brief yet enriching detour into the history of PostgreSQL, adding historical context to our learning journey. The lesson we've had today is a comprehensive overview of SQL and its application in managing databases. Beyond understanding these concepts, it's also important to on their application in real-world scenarios. We hope that you found this lesson useful and that it has brought you a step closer to acing your next SQL interview. Remember, the key to mastery is practice, so make sure to revisit these topics and practice the interview questions. That's it for today's deep dive into SQL interview questions. Remember, practice makes perfect. So keep practicing these questions to ace your next SQL interview. Until next time.